Welcome everyone. So before we start actually touching and handling and testing our router and the internals of it, I do just want to chat a little bit about electrostatic discharge and how we can safely handle the electronics and the PCB. So I'm sure that everyone watching this video has at some point in their life walked across a carpet or some other surface and then touched a doorknob or another metal object and received an electric shock. And while these shocks are not harmful at all to humans, while they may be a little jolting or surprising, they're not actually harmful to us. They can actually be very harmful to electronics, and in particular, the kind of very small electronics that we see on these circuit boards. Now, the reason for that is with an electric shock, you can actually get up to easily 5,000 volts or more. The reason they're not dangerous to humans is, of course, it's for a very, very, very short amount of time. So the amount of energy dissipated is extremely low. The reason this isn't harmful to humans is that it's for such a short period of time, and our large bodies are easily able to just dissipate any of the charge that would come from that. However, for small components, if I just grab my pointer, like some of the ones on this board here, like the chips or the other, it's even really hard to see small componentry on here. They're so tiny that this large charge across them can actually do quite a bit of damage. And the one really concerning thing with electrostatic discharge or shocking these components is that a lot of times the damage won't be noticeable right at the start and everything will function as is. However, we've weakened that component to the point where it's going to fail later on. And this can be a nightmare from a quality assurance standpoint, especially if we're working in a production environment or we're doing testing on a board for a potential customer or something like that. We want to make sure that we're not accidentally introducing this damage to the board, because then we're not entirely sure if it's something that we did legitimately with our testing or if it's from this electrostatic discharge. So if you're working in a professional setting, depending on where you're working, there's going to be a set of measures that you're probably going to have to follow for electrostatic discharge and to make sure that that doesn't happen. And I just want to go over some of those so that everyone is aware. And then when you're working at home, you can kind of make your own risk assessment about which ones you're going to follow. You know, one of the nice things in this course is the router that we're working on is relatively cheap. It's only $20. So if we do damage it, then it is easy to replace. And, you know, in this scenario, we're not actually working on a customer's component. So ultimately, it is up to you to decide how many ESD precautions you want to take. These are not like a safety precaution for ourselves or injuring ourselves. They are to stop us from damaging the board and our equipment. All right, so the first thing that I'm doing here is I'm actually working on this ESD mat. So the way that this works is it's very insulating. It's made of rubber and it has an extremely high surface resistance. So that's going to help dissipate any electric shock, because of course it's going to be hard for there to be a path to ground. Another thing that we can do before we start working is we can make sure to dissipate any charge on our body. So what I have done is, near me, I have a doorknob that's just off camera that I touched before I start working. So if you have anything similar near you, a doorknob or like maybe a metal bed frame or anything like that, you can make sure that you've dissipated any of your charge. The other thing that we can do that is free is make sure that when we're handling the board, we're not actually touching any of the components unless we absolutely need to. So if I were going to pick up this board, then I would do so from the edges and just touching the edges like so. I wouldn't like actually go and directly touch any of the components, because that can relate to a shock going straight into the component. That's why, like, when I need to point out to them, I am using this tool that is non-conductive so that there is no chance of dissipating shock. Okay, so the other things that I'm going to show here are stuff that's going to cost money, and I'm not going to be using them all because I personally feel like it's a little bit overkill for this, but I just wanted to demonstrate in case you are ever in a professional environment, you'll probably need to use those. So the first one is something that you've probably seen, and that is these ESD bags. So these bags are non-conductive, they're highly resistant, and when we're transferring or moving electronics, then we should put them in these bags because it stops any electric shocks from dissipating throughout them. So these are great for that. You've probably seen them if you've ever bought like any electronic components, they come in these bags. The other thing that you will commonly see in a professional setting is a way to actually keep yourself grounded. And I'm just going to show you one way that you can do that. So I have a power bar that's mounted that I'm using for power. It's just right here. And on this power bar, of course, this little pin here, this is just a straight connection to ground. So that's generally done for safety reasons. If we have a short circuit or anything like that, all the power will go straight to ground. And this plug that I have here, it's only got one prong and it only just fits into the ground. So I'm going to plug that guy in here, and then it's going to give us access here. I got it plugged in. I'll just set that here. It's going to give us access to two ground connections. So what I have here is a wristband, and this is a metallic, like it's got metallic conductive material in here. And it's got this alligator clip here that I can pull off. So this plugs into one of these guys. And then I can just put this wrist strap on. All right, so you just wear it on your wrist like that. And then this, what this does is this makes sure that I'm not actually going to be able to build up any charge because I am constantly grounded. So there's almost like a zero resistance path for any charge to go. And it's going to take the path of least resistance. So instead of, shocking anything, it's going to go through to ground. All right, so I'm just going to take this off because it's a little hard to film with, and I'm not going to be using this because I think it's a little overkill for this lesson. But if you're in a professional setting, like when I used to work on electronics in a professional setting, I would wear one of these. All right, and then the last thing that you can do is that we actually can ground the work area that we're working on as well. So I've got another one of these clips right here, and we've got this that plugs in on the one end, and then it's got this alligator clip here. So I'm just going to clip it onto the side of this mat. And then even though this is set to be like a really bad conductor, and it's very, very highly resistive, just in case, we can also ground this to make sure that there's no chance of any electrical charge dissipating. It will go straight to ground. Okay, so I just plugged that in again. I'll show you into my power bar that's here. So now, if I'm wearing this, I'll just put this back on again quickly. All right, so if I'm wearing this, now we can see that I'm grounded and the area that we're working on is grounded. So it's almost impossible for us to have any sort of electrostatic discharge. The last thing that you'll see in a professional environment, and is something that I have had in working areas as well, is there will also be special flooring that is very, very conductive so that it makes a good path to ground. And you'll wear special shoes that are ESD protective shoes, and they will also make sure to ground you. So I then have 3 points of grounding, and it's very unlikely that we're going to have any sort of ESD. Now, these last three things where we're using, the grounding of the mat and the grounding of the wrist strap, and obviously no one's going to have this at their home, but the grounding through the shoes are great for production environments, and we want to be absolutely sure we're not going to do any damage. However, for the home stuff, I would just suggest to sticking with the, touching only the PCB by the edges and trying to avoid actually physically touching any of the components themselves. And I also do just ground myself on something metal because it's very easy to do before I work with it. That being said, if I was working on something like my personal laptop or maybe my phone or something that was worth a lot more money, then maybe it's good practice to follow these. So I will leave that up to you as the viewer to choose which options you're going to use for ESD protection. With that being said, we can now move on to our first testing and taking a look at the PCB. So we'll wrap that up for this lesson, and I'll see you over the next one.